Okay, awesome. Hello, welcome to the most boring talk ever. Why are you all here? So this is tips and tricks, things I learned along the way, switching from Eagle to KiCad, which happened very recently. I know I'm late. So here's the kind of things you guys can expect. Why I gave KiCad another try, things I learned along the way. I want to do a quick demo of the workflow that I came up with in just a couple weeks. And hopefully that gives, again, I'm super new to this, so there's probably tons of stuff I'm missing, but maybe there's some stuff there that you'll find interesting. And we'll just kind of use a handful of tools here that you might find useful. So why would I give KiCad another try? I mean, KiCad is obviously free software. It's awesome. I've been using Eagle for 10 plus years. I have, poured sweat and blood into learning this program, like clawing my way up through every inch of productivity. Why would I throw that all away and try to learn another program? I don't know. Why would you? Yeah. And, in the early days, I mean, Eagle was the software of choice for open source projects, right? I mean, they had free licenses. It was really, really easy to get a basic, commercial license to do a little, maker type stuff and sell a couple things on Tendy or whatever. All Spark Fun, Adafruit, like everybody's putting out all these designs in Eagle. So it was awesome. And then in 2016, unfortunately, Eagle contracted a terminal case of being acquired by Autodesk. But it's okay. They promised to continue perpetual licensing. No worries. It's all good. Don't sweat it. 2017 rolls around. Guess what? Nope, subscription. And then we learned that the standalone is discontinued. They're not going to continue to make any development on it. That's okay. You can switch to the cloud thing or just keep using the standalone software. But it's not really going to see a lot of improvement. But don't worry. You can keep your Eagle subscription. You grandfather you in. All that kind of thing. I'm only paying $100 a year for Eagle, Fusion 360, all that kind of stuff. I got in on some kind of deal from the ground up. I know a lot of other folks pay quite a bit more for that. But hey, for anybody that was there during the transition, you get this. Well, we promise. Well, I'm altering the deal. Pray that I do not alter it further. And now we learn that, well, guess what? That licensing is going to go away after a certain point, coming up pretty soon here, depending on your model, somewhere between this year and 2026, you'll no longer be able to renew. And then once that yearly cycle is gone, your licenses, you just can't. You just won't. You open the program and you're going to get an error message. You're not going to be able to open your files and do stuff. It's just your SOL. So what can you do? Don't worry. You can get you can open all those things, same things in Fusion Electronics, but you'd need a full Fusion license. So, no more $100 a year. Right now it's $680. I don't know what it's going to be in a couple of years with inflation and all that sort of thing, but it's getting there. But not everything has to be a slow cloud-based solution. Of course, a lot of you all know that already. I'm late to the party. And so I gave KiCad another try. And to give you an idea, does anybody know when KiCad 8 came out? The RC? This year, yeah. It was a couple months ago? When was it? January, all right. You would know. So I gave it a try. I installed an RC, and my experience between then and from when I had tried it previously years, night and day difference. Like, it was good software, stable. It worked like I thought it should. I could intuit things. I could discover things without having to go, watch a bunch of YouTube videos or read manuals or whatever. Like, it's good software. It has, and going from Eagle, like, there's a lot of good stuff there. The grid tool, it works good. You don't have to play all kinds of weird trickery to get stuff to do what you want. Vectors, you can have polygons and do like Boolean, like intersects and negates and all kinds of awesome stuff there. And the default library with the parts, it's actually good. Like, I don't know how many people, most of the people that I've talked to and I ask about, Eagle and the parts library, most of them are like, no, skip it. Just get like the SparkFun, part library. There's a lot of excellent third-party libraries, right? And you'd all go at. But KiCad, it's all right there. And it's good. It's not garbage. Yeah, doubling it every year. And I was having fun. I wasn't fighting, tooth and nail to learn this thing. It was just like, oh, this is awesome. And I started off simple. I did a couple little projects, and I felt like I was actually productive in it, which was awesome. It does have one major flaw, just so if you haven't tried it yet and you start to try it, I suggest that you go into settings, you find this, and you uncheck it, because it will do weird and strange things to your cursor and your screen, and you'll get lost. So just beware. But of all the flaws that it could have, a checkbox that you have to set is not too bad. This is what it looks like trying to scroll around using this feature, by the way. Where'd it go? How do I get it back? Of course, the hardest part of learning KiCad is trying to pronounce it. KiCad. What? KiCad. Yeah, KiCad, I know. So this workflow that I had spent like 2 weeks learning and practicing on it blows my mind, but somehow it's better than the one that I had with Eagle that I had, been fighting with for, a decade or something. And it's awesome. So I use the KiCad library for 90% of all the things. It's excellent. It's got parts. There's 3D models even. I didn't even care about 3D until I started doing 3D in KiCad. The rest of the parts I tend to find on LCSC. I tend to get a lot of those inexpensive, there's some great parts there. I would love for this to also be, the kind of workflow that I have here to also be available in DigiKey and Mouser as well. And I think that maybe there's just a little bit of tooling that needs there. Because I know that they supply parts and libraries and 3D models and that sort of thing, but there is a script called Easy EDA to KiCad, and I should have done a QR code, Jason, thank you for that suggestion. But I have a URL that you guys can all screenshot right now. And this is the one that you want. So this one is updated and goes to LCSC, EDA. They have their own online cloud thing or whatever, and it pulls down footprints and footprints and symbols and 3D models for the kinds of parts that you would, you need some random switch or random battery holder or something like that. You can go in there and find that stuff. It's really helpful if you are then going to use JLC, PCB, or something like that to get your boards made, or do PCBA through them as well. Right, so that's step 3, get all the parts I need in there, and of course laying out schematics and, and PCBs, just drawing lines, really. Many lines, but just drawing lines. And then for graphics, I'm using a tool called Gingerbread, made by Thea Flowers. It's an amazing tool. KiCad has awesome native SVG import, so you can drop an SVG right in there. For super complicated SVGs, it is almost too faithful to all the different curves that can go on in there. And so if you pull that in and you find it to be slow, give Gingerbread a try. It goes through and it does a process where it'll kind of downsample some of those things. And so I had some of you all have this art pen that I made, and it just has tons of graphics that I had traced in Inkscape, and there's just bazillions of little corners and curves and stuff like that. And First I pulled that in, and it was just sort of bogging down, especially the copper, because it's doing all kinds of DRC checks and stuff. Used this, and it was like super snappy. The tool is amazing. Hopefully I have enough time to show you all later. And then instant 3D previews. Again, before this, I was like, yeah, whatever. I don't need 3D, all this kinds of stuff. But having your board right here update live while you're placing stuff and seeing like, oh, wow, this connector is like really big. Or if I intend to rework this, maybe I shouldn't put the little tiny thing with the little pins like in between this valley of giant components or something like that. And then later on for CAD modeling, stuff like that, the step export is really, really good. Again, a lot of you folks know this, but coming from Eagle, I had no idea just how good it was and how good it was compared to, because the main selling point of the whole integration of pulling Eagle into Fusion 360 is the 3D integration. And it blew my mind like how much better it was actually in KiCad, even with Fusion, right? So again, if you're going to JLC, there's a ton for different, a ton of add-ons for different PCB manufacturers, but there's one called Fabrication Toolkit. It's like literally one button, and you upload a couple of files, and you can get your boards made. You don't have to mess around with importing rule files and all this kinds of fun stuff. And then you order your PCBs, right? Easy. Oh, oops. Don't forget to run DRC before. It's so fast, you might forget. So run DRC. You can absolutely use the import tools. So if you have existing Eagle files and you want to maintain those in KiCad, you absolutely can. There's imports. I found that it's way more fun to just completely kill it and grow a new PCB out of the bones. I mean, you should just really just become a PCB necromancer. Just kill it and use the bones to form something else. The KiCad parts are better in general. Again, so like, you know, where I would go to even a third party or something like that, like the SparkFun Eagle libraries and things like that, I'm blown away with the quality of the library in KiCad. It's awesome. I mentioned this earlier. I'm skipping ahead. The 3D step files that I can get out of KiCad and then pull into Fusion or any other program, just really, really good. And of course, you might actually enjoy working on PCBs again. So you can totally open up an Eagle file, and you'll still have all the same symbols and footprints and all that sort of stuff, or you can start tearing it out and replacing it with stuff that's just a little bit better. Of course, you can always just take off and nuke the entire site from orbit, right? Sometimes it's the only way to be sure. Yeah, so this is an example. This is a board. This is probably like my 4th board that I spun with KiCad. It's an iteration on the Pixelblaze LED controller that I have using Ethernet, dropping them back in there. There's a bunch of high-speed lines and stuff like that. Some fuse holder parts I had never used before. I was able to pull in the 3D of this and making sure that I can actually have accessible fuses and things like this. Plopping in a special red-blue LED, checking that out, making sure all the stuff's in the right place. The 3D actually really ended up being incredibly useful. And I can, the only thing that it was missing was this JSD connector on the top right. 99% of this, I had to touch nothing to get 100% step export. Colors, everything. It blew me away. I don't know if anybody has done the Eagle thing, but like you can go in there and you can take your Eagle PCB files and then export it to, or not export it, but push it to a 3D PCB, and that takes a while. And then you can import that 3D. You can't obviously model that 3D PCB. You have to pull that into mechanical design. And then if you go and you make a change, like let's say you want to go and update that library that you have and make sure that you have an actual footprint instead of just a weird little rectangle that doesn't really look anything like it at all. There's like a million steps. You got to update and save this. It's faster to just export a step file and import it again from KiCad. It's amazing. All right. So if we can, I want to show you this process, and I'm going to try to. I'll do this. All right. So we start off with a schematic, and I'm going to do a little art badge pin thing, and it's just going to be super basic, just to give you an idea. We'll do a couple LEDs, because you have to have LEDs. A battery of some sort, maybe a switch. You probably want a resistor in there. Let's start with the resistor. So I hit A to go in here to the Add Part dialog, and it starts you right off at the filter. And I know that in this library they have a naming convention with R underscore that gives you kind of a filter right down to all the resistor stuff. And I like the US symbol, because I like the squigglies. It's just what I'm used to, so I'll get that. Let's zoom in a little bit. Can drop a resistor. All right. Now for a battery holder, I want some sort of CR30, 2032, pretty standard coin cell kind of thing, 3-volt lithium. Not a ton of current, but good small size for things. And I'm just going to go over and, uh-oh. Where am I? There we go. Go over here, and I found a random part on LCSC, something that I wanted. It looked pretty decent, nice contacts, stuff like that, a nice kind of case to kind of hold it in there. So you can do metal clips and stuff like that, but this seemed like pretty nice. And I just copy this ID, basically, go down here and run this easy ADI to KiCad, paste in the ID here, and it pulls it into a KiCad library for me automatically. Switch back over here, and I can hit A. Oops, I haven't copied it yet. Copy the ID. Oh no, I've crashed it by pasting too much. All right, well. It wouldn't be a live demo, right? Let's put that resistor in there. I should have saved. All right, so I just pasted in that ID. It's already pulled it up here. So I can take that, drop that in here. We've got a battery. Now for LEDs, I started using side-lit LEDs on these PCB things, so I can put the LEDs on the backside and it'll kind of shine into the FR4 and create kind of a nice diffuse effect without blinding your eyes, which is totally fine, by the way, most of the time. And I had found, right, so they have this whole thing for, what is it? They call them side stickers. So that's what, if you are curious, side stickers are the kind of LEDs that you want to search for. No head red here. Let's do blue. What's that? Yeah, brick nogging. What? So while I search this, what is brick nogging?
It's like Yeah, so with LCSC, sometimes the terms used are interesting, and part of the fun is figuring out what is the translation of something that you usually know. So, I'm used to using like vertical surface mount connectors, and I was getting really confused because like this was not a parametric search option in LCSC, and apparently that is called brick nogging, and now you know.
Thank you. Thank you, Carrie. That's all right. All right, so I have found a blue LED over here. I'll just copy this ID. I just make sure that there is a Easy ADA has the schematic and stuff in here, and usually that means they've got everything. I've found a good 90% plus of their library, which is impressive, has everything. Right, so this looks like it pulled down a step file too, a WRL, the whole thing. So I'll go over here and I'll hit A and just paste that in, and there it is. So I didn't have to do anything really to get this in, and I love cheating like that. And we need a switch, and I had a switch picked out and already imported. Let's go over here, this one. As long as I don't paste in like a megabyte of text to the search box, apparently, yeah, maybe I'll file a bug report. I don't know. That's not really a common use case, is it? Nice. Yeah, well, I did. That's exactly what I asked it to do. Yeah. So I click, so I haven't had to switch tools really. I can just kind of click, and you see my cursor kind of change. So to wire stuff up, it just kind of automatically switches to the wire tool. And I'm going to wire that up here. We'll wire this up here. Yeah. Okay, I'm not going to do that in my demo, but I'm going to try that later. That sounds cool. I didn't. This is great. I'm learning. See, I'm a noob. I'm learning on the fly. This is awesome. All right, so the one thing I haven't done, so these other three parts, they're like an exact part. But that resistor was a generic, abstract concept of a resistor. It has no physical manifestation yet, so I'm gonna click on it here and hit E to edit, and I get all the property dialogues and stuff like that. So I go in here, and I can actually put in a value. So I want 330 ohms. I'm not gonna do the math and bore you with all that kind of stuff, but it should be okay. It's not gonna be too bright, not too dim. And I want a footprint, right? And I'm going to do a surface mount because I don't want a big, resistor on a nice art badge or anything like that. And it's going to go through a pick and place machine and stuff anyway. And I know that this one is going to be R_0603. They have a really nice naming convention, so it makes it super easy to find this stuff. All right, so I've got my 0603 330 ohm resistor. Now with all that kind of dialed in, I'm going to switch over to the PCB, and I'm going to hit this update button. And so unlike an Eagle, where an Eagle you have to have the schematic and the PCB open at the same time or things start to go crazy really quick. In KiCad, you use this button to basically synchronize them, and it gives you way more control about how it's doing it and what it's going to do. It tells you what it's going to do before you do it so that you can change your settings and make sure that you haven't screwed something up horribly. It has this really cool option where by default all of the parts that you create in your schematic have a UUID, and that'll link basically with the exact same instance of that part. And you can rename things and it follows through with that. Or you can use this relink thing. So you could delete a part completely and put back like another R1 or U1 or whatever your designator was, and then say relink based on the symbol reference, and then it'll relink those UUIDs. So it's actually pretty cool. It took a second for me to kind of understand what this was going on, but it's a nice, powerful tool. Once I hit update, it looks like this is going to add a couple of components, obviously the missing components that I don't have on my PCB yet. And you can see it's kind of already stuck to my cursor, so I can place it. It's not dumping it off on the corner out of your board somewhere, and you got to go get those back in somehow. So it's kind of nice. If you're doing incremental changes, it makes it a lot easier to get this thing going. I'm just going to plop those down right there. And I had mentioned earlier the gingerbread tool. What I have done with Jason's help is create just a simple SVG vector art in Affinity Designer, and then exported that as a SVG, and it basically has a layer for each kind of KiCad layer. So I've got like a copper layer, I've got a mask layer where I want to pull away the solder mask, I've got a silk screen layer, stuff like that. And we can drop that right into this gingerbread tool, and it'll give you a live preview and everything. And this blew my mind. This blew my mind. You could download this and import it and all that stuff, but there's this little clipboard icon. This is the most understated button ever. You press this button and it is in your clipboard. You just go over here and you hit paste, and you've got the whole thing. It pulled in all of those layers. It's amazing. So I'm going to select all these things, and I want them actually on the back side, since my artwork was not mirrored or whatever. It's like what you're going to be looking at. So I'm going to hit F to flip those around. I don't have to do this weird thing where I select a group and then right-click and do the. It's amazing that it actually works intuitively. Like 10 years of expecting it to just be such a nightmare headache. So we can drop this. Oops. Let's zoom that in a little bit so you can see. All right. So we have this huge battery. Let's kind of slot this in here somewhere. Let's go right about there, just so it's not in the way. Now, I don't know if you saw on the previous screen, but I have pulled the mask away from the front and the back of the PCB, and the PCB FR4 material is slightly transparent. So I'm going to have an LED on the back that's a side view LED, but part of that's going to be shining in, and it's going to glow through. It's a neat trick for doing glowy art PCBs. Now I've got this switch here, and I'm just dragging it, and I'm going to press R to rotate it a couple times, and we kind of want to put it over here on this edge. That looks pretty good. It's not perfect. Sometimes, like this, whatever this weird blob thing is, that's the actual little switch toggle thing, but I get the idea. Let's put the resistor down here. Oh, that's the LED. LED. Right, so this is the blue LED, and we're gonna go over here and kind of face down. And we get this resistor here. Oops. Oops. All right, so sometimes you're dragging weird bits out of the thing. Like I don't want to move the text, I want to move the whole thing. Awesome. Oh, down here? Is that what? Who thought of that? That's amazing. All right, so if I don't want to move all those weird things that I'm not trying to move, I just uncheck these checkboxes. Awesome. Man, I'm learning more than y'all are. All right, so we got... Okay, now I haven't drawn I've got a couple lines I haven't drawn, so instead of air wires or whatever, we've got these, and they're nice. You can cause them to curve, they follow around nicely. It's amazing. Yeah, the colors. You can have colors per net. What do you think of next? Subscriptions? So I'm just hitting X. X is going to start drawing some wires. I could go through and I could define net classes of minimum widths and all that kind of stuff if I've got, power signals and all that kind of stuff. For this little low current stuff, I'm just going to not bother with that. Let's drag this over here. And you see I've got these nice, 45-degree angle lines. Yeah, that sucks. That's boring. Let's drag this over here. I'm going to hit Command/, and I've got curves automatically. Look at that. Curves. And I hit slash to toggle the direction. I can do the tricks with the mouse too, like get it to kind of, anyway. Slash go this way. Look at that. Gorgeous. Go down here. I know, it's one of my favorite features, honestly. Okay, I'm just gonna get this going here. All right, so I've wired the board, right? Now we can buy it. Let's eyeball it real quick. Let's see what this would look like. Before I do that, I'm gonna go in here and set some things up because I have a stack up here. And instead of not specified colors, I know that I wanted to go with a white solder mask and black silk screen. So this is the silk screen. I'm gonna set black, do white for the mask. The dielectric, I'm gonna say do an FR4 natural. And then again, for the bottom layers, white and black. All right, so with that in place, I know it was a lot of setup. Thank you for bearing with me. I'm going to press this button up here, and we have a 3D preview. Wait, but that's flat. That's not 3D. Oh, wait, that's the front. There we go. Look at this. It's gorgeous. Even with transparency through the FF4, you could kind of see through to the other side, so you get an idea of what's going on here. I mean, it's awesome. Yeah, so I didn't have to go through. I didn't have to, model all my own stuff. This workflow, is very, very specific to LCSC, but it's incredibly powerful, and I really hope to find, maybe there are tools already that exist out there that are just as easy. I'd love for this to learn more about this kind of stuff and use parts from all the different distributors and, have tools for all the different board houses and things too. But yeah, so if you do want to buy the board, the fabrication toolkit, you click this button, it dumps out everything you need. You just upload the files. It's already got the Gerbers in the right format. It has the position placement data. It's got your BOM. It even references, there's a couple of different ways you can do it, but if you have an LCSC ID for many of those parts that we've imported using that tool, it automatically figures all that kind of stuff out. Everything else is named in a way that usually the tool on their website will automatically pick, like that 330 ohm resistor, it's probably going to pick a decent choice, but you can obviously go in there and customize that. So, I mean, it's mind-blowing to be able to do something like this using parts that I haven't touched, I haven't used before with this kind of workflow. Thank you.